And good afternoon, everyone. Welcome, and thank you for joining us. I appreciate it. So real briefly, every webinar presenter or speaker has to do the requisite "I'm proud of who we are" slide. I'm not going to read this to you. Bullet point: we deliver business processes and solutions to solve complex business problems. And we've been in business in the St. Louis market since about 1981. We're a gold partner. We have 10 gold competencies, and we're a managed partner and cloud economics partner. So that's who Oakwood is. So the gist of what I'm covering today, and so let's think of a business use case. You've got an on-prem SQL database or several on-premises SQL databases or an operational data store. You've got data in several of these places that you'd like to query across them, but you don't want to have to do a bunch of data movement. So data virtualization allows us to look at or query or view our data in a variety of ways from a single virtual layer without having to use complex ETL or ELT processes. And it's a couple of the definitions I threw out here for you. Depending on who you're reading, whether it's Microsoft or Gartner, or Forrester, Cognizant, there are different definitions of data virtualization, but the one that I like is the bottom one. From Forrester, a real-time agile data integration methodology or approach that provides you a logical view of your data. This is just a high-level logical sort of architecture diagram that just sort of shows what's going on with data virtualization. So you have a variety of data sources, either in the cloud or on premises, that you're going to pull data from into this virtual layer using Microsoft SQL PolyBase query language. And then you're going to be able to view that data in the virtual layer, on that virtual layer, and report against it. So this is sort of what that looks like graphically for you. One of the things that I want to highlight, or I like to highlight, and this starts to get into some of the benefits of data virtualization versus data movement or using complex ETL and ELT processes. You know, it's more costly to build and maintain those ELT jobs. So if you don't have to do that, if you can find a way to get around that obstacle by virtualizing some of your data, then you're going to save some time, some money, additional effort on the developer side. You don't have to worry about duplicated data storage costs. So these are all the benefits from development, time to solution, security, your data freshness and quality, using a virtual data source that's already real time, pulling that data in. Allows your data to be fresh. I have worked on projects with enterprise data warehouses of gigabyte up to terabyte in size, and some of the complex ETL packages that we would write in SSIS could take 8, 10, 12 hours overnight to run. If I'm not having to do that every night, the data is a lot fresher and it's more real time for me. So some of the benefits of data virtualization obviously reduces the risk of data errors, so I'm not having to move data all over the place. Reduce workload. It does not attempt to oppose a single data model on the data. Reduce data storage costs. Increased governance. Allows for the integration from multiple sources, locations, and formats without the need for data replication. And again, at a high level, I'm just speaking to data virtualization in general, and in a bit we'll get into the SQL Server 2019 pieces and how Microsoft has implemented this. Data virtualization may offer or provide a variety of capabilities in terms of managing your data. Being able to abstract the technical aspects of stored data, such as location, API, language, etc. Connecting to different data sources and making them accessible from a common interface. So you have the virtualized data access, some ability to transform your data as you're reformatting it, as you're mapping data between tables, as you're setting up the virtual layer. It allows for some form of data federation, data delivery. So these are some of the capabilities that come just with data virtualization in general. There are potential drawbacks though. So for those of us who well, I won't tell you how old I am, but for those of us who've worked in the technology space for a long time, every technology that has its pros also has its cons. So data virtualization does have some potential drawbacks. If you're working with, or you have a number of large operational data stores or operational systems that you're trying to aggregate data from in a virtual layer, and the queries become complex, it could have an impact on some of those operational systems. So if an end user needs to run a report or is pulling data for something else, and it takes a significant period of time for them to do that because we're putting a bottleneck on the system, that might cause a problem. It does require some defined governance to avoid budgeting issues when you're getting into shared services. And for those of you that do a lot of complex business reporting or financial reporting, if you're having to do month over month, quarter over quarter, or year over year type reporting, where you need to save historic snapshots of your data for rolling reporting, that's probably not suitable for that. You're still better off using a more classic Kimball model enterprise data warehouse. Change management can also be difficult, as when you're virtualizing the data layer, everybody who's accessing that data across your organization, the various stakeholders, have to agree to the changes that you're making. So change management can become an issue and needs to be managed. Okay? And related to the drawbacks, data virtualization is not a be-all to end-all or a panacea. There are certain cases where you simply shouldn't try to do it. Operational systems or data stores where your response times need to stay around sub 2 or 3 second response times, you're going to run into some success issues with your end user population. There may be instances where you have to impose a heterogeneous data model, and that's a requirement. It's one of the use cases. This is probably not going to be your best option. And again, building historical data snapshots. If there's a significant data transformation need or use case, if you're pulling data in from several data sources and you're having to do a ton of transformation, you're probably not going to want to do it in a virtual data layer. Some of the common business use cases for data virtualization in general, we've seen people use it to build out virtual data warehouses or virtual data lakes. A common use case that I work with or use internally and with some of my clients is being able to do prototyping for physical integrations and defining requirements around the architecture and being able to develop a logical architecture. Also, if I'm working with a client who's interested in data virtualization, want to understand how that works, coming in and helping them define a proof of concept or proof of value, where we come in and work with them to massage some of their data and to use small subsets of their data to build out a often, maybe McKinsey or some of these folks, what they have to say about data virtualization, or if you go back historically, as data virtualization has been a concept. Conceptually, it's been talked about by folks in the IT industry since the 80s. But a lot of times they sort of confuse or talk about data federation and data virtualization synonymously. And in many cases, they're not really completely or 100% synonymous. They have some subtle differences. Data federation, especially currently or modern day, is typically a term used for techniques that resemble virtual databases, and they're maintaining a strict data model. So the big key to data federation is we still have to maintain a strict data model, whereas data virtualization, we don't have to impose a strict data model. We can provide a single pane of glass to the data without having to impose a strict heterogeneous data model. So that's the biggest distinction. And this just is another slide that just shows or demonstrates the distinction between them. So the Microsoft story. Prior to SQL Server 2016, there was no option from Microsoft to do any level or type of data virtualization. And if you were a Microsoft-centric shop, if you wanted to maintain all of your operational systems, all of your back office systems, your office productivity, if everything you're doing is in a Microsoft context, most organizations don't want to have to step outside of the Microsoft ecosystem to do something. But prior to SQL 2016, you had to. There are some other players in the market, such as Denodo and Tibco, to name a couple. But with 2016, PolyBase provided some limited data virtualization capabilities, specifically against data stored in Hadoop and Azure Blob Storage. The most anticipated probably feature of SQL 2019 that we read about a lot last year through beta and preview and so forth was the data virtualization feature set that Microsoft was expanding and providing with SQL Server 2019. And the data virtualization in SQL Server 2019, as you may be aware, is accomplished through some pretty significant enhancements that have been made to the PolyBase tool, and then using an external table to aggregate views of your data. And when we send the slide deck out to all the participants, I included a link here that sort of talks about that, provides more information around the PolyBase product and what it's doing for us. PolyBase is used to connect to numerous data sources and file formats. Also, with the advent in SQL 2019, big data clusters and enhancements to PolyBase working together allow us to create a virtual data layer to integrate structured and unstructured data. So we're not limited to the structured data coming out of an operational data store or data warehouse. We can also pull data from unstructured or semi-structured sources, and now across your entire data estate. And now we can push that data or aggregate that data across all these other products: SQL Server, Azure SQL Database, Data Warehouse, Azure Cosmos DB, MySQL, etc. You can virtualize the data in a SQL Server instance so that it can be queried just like a table in SQL Server. So the first thing you want to do is you're preparing to embark on the journey in your organization with data virtualization is installing and configuring SQL. So if for my use case and for this demo, I've already installed SQL Server 2019 Enterprise Edition locally on my laptop. So a couple of notes about the SQL installation, and you can also do this, by the way, as an IaaS SQL instance in Azure, SQL managed instance, etc. But I chose to do some of it from a SQL Server on-prem. So I installed a new SQL Server standalone version. I used the enterprise version, which came with a key for me out of my MSDN. Obvious, some of the obvious screens that you see are probably familiar with these. The important thing is as you're going through the SQL Server configuration and setup, as you're installing the product, when you get to the feature selection screen, you need to be sure you select PolyBase Query Service for external data. You need to have that service installed to make this work. If you've already got a SQL Server instance installed, you can always go back and rerun your SQL Server installation application and select that service and then go ahead and update it. So that's always possible. But you need to have that feature installed. And then once you've got SQL Server installed, either using the SQL Server Configuration Manager or Windows Management Console, you need to go out and look at your SQL Server instances to see if these services are running. So with SQL Server 2019, by default, the PolyBase service is automatically is running for you. You don't have to start it. Earlier versions of SQL, that was not on by default and did not run by default. So you can just go into your configuration manager and check that. The next thing you need to check is in enabling the TCP protocols in your SQL Server instance. And again, you can do that from your SQL Server configuration manager. I mean, I did screenshots of it to show it, but I can show it to you live as well. So you just need to be ensured that those services are installed and running. Then next thing you need to do is download and install Azure Data Studio. So Azure Data Studio is a new product that recently came out of preview that allows you to view and access databases across your data estate, both on premises and in the cloud. So you can create connections to your data environment that's sitting in Azure. So you want to be able to install and configure that product. But once you've installed Azure Data Studio, so I got a screenshot of it, but I'm going to actually go to it as well. So I've got a Azure Data Studio application installed on my local device, up and running. You see here, I've got a connection to the local instance of my database server, and then an instance I've created out in Azure as part of this process that I can connect to. So the first thing you need to do is there's a couple of PolyBase services that are not running by default. So I need to go in and configure those. And so you do that by selecting your database, going down to new query. And the first thing I need to run these commands, execute spconfigure config name equals. So I'm enabling PolyBase, and then I need to execute a command to allow PolyBase export, and then run the reconfigure command. Now, if I want to validate that that's actually been done, you can see that it ran. Then I can go back in here, and I'll just create a new query so it's not as confusing. And then just type sp_config. Oops. That's not going to work. Anyway, you run that command, it'll pull up a little table here that shows that your variable has been set to 1, which is what you're looking for. Next thing you need to do is launch the Azure Data Studio, and there's an extension file that we need to load in the environment for all of this stuff to wire up and work. In the earlier preview versions of PolyBase and SQL 2019, it was an extension that was simply called SQL Server 2019. That's recently been deprecated, so I'm going to be loading the data virtualization extensions. I've already done that in my environment, so I don't want to have to do it again. But you go down, you click here, this icon that's extensions. You'll see I've got that data virtualization extension already running. But if it's not installed or running for you, you find it by coming up to in search. Just type data virtualization. And then you see the extension, click on it, and then install it. Right now, mine says uninstall because I've already installed it. If it has not been installed in your environment as yet, you'll see install here. You click the button, and it automatically downloads it, installs it, and does everything for you right here within this interface. In the earlier preview versions of this, the SQL 2019 extension that has been deprecated, you had to download it and then install it locally. But Microsoft's done a really nice, clean job of automating that for us and making it easier to download and get running. So the next thing we want to do is to create an external table. And there's actually 2 methods to do this. One is manually creating your external table with the T-SQL commands. And there's a whole bunch of them. If you have to create a table that's going to be somewhat complex, if you do some different naming things with the columns, etc., you might want to use T-SQL commands because it gives you more flexibility in setting up the external table. But if you've got a very simple table that you're going to create from one database source, there's an external table wizard. It's a real nice, clean interface to do this for us. Both of these methods involve the use of Azure Data Studio. So I've got screenshots for it, but I'm going to see if it works in the live environment. So the first thing we do is go to there's 2 methods to get to the wizard. One is I just double click my database, and on the right hand pane, the large window, click data virtualization, and I've got a nice little create an external table icon here. Or I can go directly to one of my databases, and I've got the default Microsoft Worldwide Importers database in my environment. I loaded that in there. I right click that, and then I have another command to get to creating an external table. And as I've been working with this the last couple of days, it keeps you running into network issues, and it either runs real slow or it bails out on me. So we'll see how it goes, try to do the live one. Otherwise, I do have screenshots. So the first thing you need to do is, since I right clicked on my database and clicked create external table, it automatically populates this field for me of the database that I'm using. SQL Server is generally going to be my default. That's where I'm going to create it. Then you have to create a master database key here. It's a requirement. You can't get past it. And it secures the credentials that are being used by the external data source. So I'm going to enter a password here. And if you're like me and tend to occasionally fat finger things, you might end up with passwords that don't match and it'll squawk at you. Oh, they matched. Great. So there's a few variables that we need to enter in here before we get to create to the tables. The external data source name, that's the just a name we're giving it in the system. It can be anything you want. You can just type anything in there. For my purposes, I've been using PolyBase test. The server name actually has to be a real name of a server where you're creating the external table. So in my case, I have created a simple Azure instance of SQL, and I use the server name and fully qualified domain name. Put that in there. Then put the name of the database that you're wanting to create, or the table. And then the next step is there, you have to have a scoped credential because we're accessing an external system that's external to our database environment. We have to have a scoped credential for that connection and for that database. And you have to give it a name. The credential has to have a name. It can be anything you want. I'll just put my test cred. The username and password has to be a legitimate username with authority on the source and destination systems. And this is the point where where my system usually bails on me. So we've gone through these screens in the actual live environment, so I'm just going to breeze through them. The next thing it does, it's going to pull up a screen that shows your maps data sources. So I select, a table that I'm wanting to map, provides a screen where I can map fields from source to destination. I left the defaults for this particular instance. And then you create the table. There's a button to create it, and then it goes and it runs a sample query and then populates a table. So you can see that we've created an external table out in our Azure instance of SQL, populating it with information from a table that's sitting in my on-premises SQL environment. So in summary, my focus today was to simply define and describe data virtualization and talk about the Microsoft story, and then just a little bit about how you're going to get started. So that's about as far as I take it today. Any questions?
Last call for questions. Otherwise, we will let you move about your lunch hour.
So what we like to do next is follow up to this is if you are interested in a deeper dive around data virtualization, reach out to the data and analytics team here at Oakwood. We'd be happy to come on site and do a lengthier briefing. We have a briefing offering around some of the products that we support and implement for our clients. That could be in the form of a hour-long or 2-hour lunch and learn. We could actually do a deeper dive demo. So if you want to see more of data virtualization with SQL 2019 in action, where we actually go in and pull data from a few sources, aggregate it in a virtual view, and then do some reporting against it, we're happy to set something like that up. If you would like to do a small proof of concept within your organization to prove out something related to data virtualization, or to see if that's something that would work for you in your environment, we're happy to have a conversation around that. And one of the things that I always like to offer is, so as a gold partner in the St. Louis market, and then I personally also know Meryl Shabaum, who's the head of the Microsoft Technology Center down at Cortex. Microsoft offers a number of architectural design sessions around a lot of their products and innovations. And we would love, if your organization would like to join Oakwood at the Microsoft Technology Center for a 2 or 4 hour workshop or a deeper dive architectural design session around things related to data virtualization and how you could integrate that into your environment and do reporting against it, et cetera, we would love to host you for that. So by all means, reach out to us here at Oakwood and we can get that set up.